Hey, Alex. Hey, YouTube.
Hey,
Hey,
everybody.
so great to have you here on the channel for a moment, and in just a minute on Talk Python. So it's going to be a lot of fun. We're going to get this look you had inside the Language Summit this year, which is very exciting. There's I think maybe more than normal, pretty exciting things going on there. So anyway, let's get into it. And those of you out in the audience, thank you for being here. If you got thoughts, ideas, questions, comments, put them in the live chat. If you're here live, if not, thanks for watching the replay. Alex, welcome to Talk Python to me.
Thank you. It's great to be on the show. Big fan of the pod.
Oh, thank you. Thank you. It's fantastic to have you here. There's so much going on with the Python Language Summit, especially this year. I think there's quite a renaissance of new ideas to sort of look at the foundations and the fundamentals of Python. And a lot of it has to do with speed in different aspects. Maybe that's through threading or through raw performance or through reference counting and garbage collection. And so we're going to dive into all of those ideas and more by just talking about your coverage of the Python Language Summit 2022. It's going to be super fun. But before we get to that, let's get to your story. How did you get into programming in Python, and how did you get inside the Language Summit anyway?
Oh, yeah, sure. So I started programming actually only around 2 years ago. Wrote my first line of code during the pandemic. Started off as a hobby. Still actually is a hobby. Had to have something to do while staying indoors.
Exactly. Yeah.
So Python is it's my first language, and I'm entirely self-taught. And once I started, couldn't stop.
That's cool. What kind of things were you looking to build? Were you just looking to learn a language, or did you have some idea of something you wanted to create?
So I was doing a journalism master's at the time. And there's a sub-community of journo coders. So people who use programming languages to gather data, scrape the web to find stories, essentially. So I thought that sounded pretty cool.
Yeah, that sounds very cool.
Yeah, so I started learning Python to help with that. And then sort of started to realize I actually enjoyed Python quite a lot, just for its own sake. So I started built a card game using Pygame. Was one of my first projects, which was a lot harder than I anticipated.
All the first projects are.
Oh yeah, definitely. And then built a bad website using Flask. And then eventually started contributing to open source, and that's about where I am now.
Fantastic. Yeah, that's really cool. It's interesting that you bring up journalism. I had Carolyn Stransky on a little while ago, predated the pandemic. Did it? Yeah. Maybe not. I don't even know when the pandemic was. A couple of years ago. Anyway, we talked
Looks
about
like you
Python.
just hit before the
just before it really kicked it. Exactly. And we talked about Python and AI in journalism, and there's a ton of neat things that people are doing to sort of automate the act of gathering data and reporting on it, right?
Yeah, no, it's a really cool space. I'm not directly employed in journalism as my full-time job at the moment, but it's something I'd love to go to dip into again at some point, definitely.
For sure. Yeah, Carolyn was talking about things like monitoring certain websites, like the National Geography, whatever the foundation is there, that alerts people about earthquakes, and I would bring up details and sort of pre-fill. So like some folks in LA, like on the LA Times or something, would get an alert. There's an earthquake. Here's most of the details. Just put the details around it and hit publish. Within 10 minutes or whatever. That's pretty cool. Little beep and then like, go write your article now.
Well, one of my first projects I tried to do, again, biting off much more than I could chew, was there's in the UK we have this body called Historic England, which catalogues England's old buildings and heritage assets. And I have this all online, but it's not like in an easily downloadable form. You know, you can't just like download the CSV of
Sure.
the National Heritage List. So I decided I was going to try and scrape this from the website. And of course, the scraping is easy, but then the data cleaning is a nightmare, because like there's no consistent format, and some of it's from the 1950s, and yeah, it's horrible.
Well, it would have been cool if you could have gotten it right and shared it with everyone.
I got somewhere there, but yeah, just way too way too difficult for one man who's like just started learning a few months ago.
Yeah, of course. Well, it's those kinds of projects that are really good for learning programming. You know, they're
Oh yeah, I learned a ton. I don't regret it at all.
yeah. You're like, here's my goal, and then you just start frantically searching for like, well, what are the steps I need, and then how do I make those steps happen in my programming language, Python in this case, and like.
Yeah.
You might not normally care to figure out how do you parse a CSV file off disk, but you're going to have to do it now because you're trying to aggregate on add onto it, append onto it, and so on. So yeah, those kinds of things are great projects.
Yeah.
Cool. All right. Well, how'd you get into the Python Language Summit? From the journalism angle, from the open source angle, what was the story here?
So I was invited in the autumn, I think, to become a triager with CPython. So at that point, I'd contributed a lot of documentation fixes, just something I was pretty good at because of the journalism masters. And yeah,
you actually know how to write, so
yeah, I'd also contributed code to a few modules at that point. A few small fixes to I think functools, enum, a few standard lib modules. So so I'd been invited by Ken Jin, who's one of the typing module maintainers, to become a triager in the autumn. So that got me onto the CPython developers Discord channel. And then in, I think it was February or March, there was a discussion there where a few core devs were asking who they were going to invite to become the blogger this year. And I sort of said,
Alex does journalism.
Yeah, like I've got this master's. I mean, could maybe I do it? And they said yes, which is very flattering.
Yeah, fantastic.
And great of them. And I really, really appreciate it. So it was Ukash, Mariata, and Sentil this year who organized the Language Summit. So massive thanks to them for inviting me to be the blogger this year. Hugely appreciate it.
Yeah, that's great. You must have been also at PyCon then, I'm guessing, because if you're at the Language Summit, you're at PyCon. Yeah, what was your experience there? Was it a good time?
Yeah, I had a blast. It was great. Just awesome to meet all these people I've been, doing open source stuff with online for several months. It was really cool.
Cool. I really appreciate these conferences because there's people I work with or talk to in different ways through GitHub, through Twitter, through the podcast, but you don't really get to see them in person because they're halfway around the world until you show up and have a beer together or hang out together.
Yeah. I think that was. I mean, the talks are fantastic. But yeah, that was definitely the best bit for me. Was actually,
that's the same for me. Actually, that's the thing that I dig the most. All right, let's talk about the Language Summit.
Sure.
So maybe tell people really quickly, what is the Language Summit?
Sure. So the Language Summit is an event every year that happens just like the day or 2 days before PyCon itself starts. So it's most of PyCon is available to just like anybody who's interested in Python, but the Language Summit is generally only available to like core developers and special guests. So it's a bit exclusive. That's not because they want to be like secretive about what's happening in there. It's more so that it can just be a sort of frank conversation between friends, I think, sort of, if
Yeah.
that makes sense.
Yeah. That's where the
Um,
business of planning out Python gets done, right?
yeah, exactly. Yeah,
It's not the only place. We have our peps and we have
yeah,
other places where conversation happens, but it seems like one of the places where, you know, some of the ideas of the peps are discussed and there's a quick feedback loop amongst a lot of the core developers.
yeah, exactly. I think it's just, get everybody together all in one small room, talk Python for a whole day, and then see what comes out of it.
Awesome. How many people show up there? How many core developers and other folks?
Around 30 this year, I think. So mostly core developers, a few triagers, and a few special guests. So Zach Hatfield-Dodds, I think, from Hypothesis was there. Sam Colvin from Pydantic. So yeah, a few open source maintainers outside the core dev team as well.
Right.
Yeah.
Yeah, Pydantic's interesting. Obviously, a great library. It's interesting to me because it kind of, a lot of its meaningful functionality is in the way that it breaks with the tradition of Python. You know, in the sense that like type hints now all of a sudden don't just mean something, but like they are the core way in which that library works. Whereas like most of the time, it's a suggestion or a hint, as the name would suggest.
Sure. Yeah. And in the way it's quite coercive as well, so you don't have to like. Yeah.
Yeah, for sure. It's so he's a good guest to have because he's both got a popular project and one that's kind of an outlier to
it's
some degree.
Hugely popular, isn't it? So
yeah, it sure is. We've got SQL model by Sebastian Ramirez, which is basically take Pydantic models on top of SQL Alchemy, and you've got Beanie from Roman Wright, and there's some other ones that are just like sort of using Pydantic as their layer, which is really cool. So obviously the reason we're chatting today is this year's summit was covered by Alex Waygood. That's awesome.
That's me. Yeah.
Yay. Nicely done. And so when I saw this article or series of articles, I guess you might say, come out, I thought it was really fantastic because, like I said, I think there's just so much that's exciting going on here. No, it's not, well, we're going to change the language a little bit here or there, but there's stuff that everyone's going to get.
There's some really huge stuff in there.
Yeah, absolutely. So I thought what we could do for our conversation is just go in order and just sort of chat through them. You can give me a sense of what it was like to be in the room. What are some of the main ideas of each of these? And we'll just chat about them. So the first one was a very exciting project by Sam Gross.
Yes.
Who I think works for Meta. Yeah, I think
he does,
part of the Cinder stuff. Yeah. And this is Python without the GIL or no GIL. Yeah, go ahead.
Yeah. Sorry, I don't think he's on the Cinder team, but yeah, he is working at Meta. Yeah.
Right. Okay. Cool. Yeah. There's other stuff from Cinder we'll get to later.
Yeah.
But yeah, Python without the GIL or his no GIL story. There's been from a historical perspective, we've had attempts to remove the GIL or change the performance characteristics of the GIL and so on. And maybe let me just set the stage a little bit with this GIL or global interpreter lock for people listening. When I heard this, the global interpreter lock means you can only run one statement of Python at a time, even if it's happening in multiple threads. I thought, okay, well, this must be some odd constraint put on the language so that things like threading are easier for people. But as I learned more about it, the real purpose of the GIL has nothing to do with threading per se. It has to do with memory management.
Yep.
Right. Yeah. So the way memory management happens in Python, at least in the primary first pass sense, is it's reference counted. So everything, numbers, strings, classes, dictionaries, they all have a ref count. And if that ref count ever reaches 0, it gets deleted as long as there's no cycles. And the problem is, if you're going to change that number on the object, normally you would have to do that in a thread safe way. You will lock it. But that turns out to slow single-threaded Python down a lot when it's unneeded. And so the global interpreter lock is there meant to basically allow for that reference counting to happen quickly in the single-threaded case. And that made fantastic sense 30 years ago. now that we're sitting here with our 16 and 32 core CPUs, all of a sudden we might want to run more than one thread and get stuff done. You know what I mean?
Yeah, yeah,
Yeah. So that's the history of the GIL, and so there were other things like Larry Hastings. He was there, right?
yeah. Just to interject for a second, it's really fun to see sort of how long a project it has been to try to remove the GIL. You can go back sort of 10 years ago, and there's a talk by David Beasley on like weird things going on with the GIL in 2010, or and then I was while I was writing this after the summit, looking through the archives of past Language Summit bloggers, and like I think there's like 3 successive years running where there's presentations about the latest project to remove the GIL. But like this time, it actually seems like it could happen. So it's really cool.
It could happen. Yeah, it certainly could. Sam Gross's work seems to be the most likely candidate. And all the other attempts, their challenges have been, yes, you might remove the GIL and you might make the parallel computing faster, but you're going to make single-threaded Python so much slower that we don't want to accept it, right? If you could say, well, you can use all the cores on your machine, but now everything runs half as fast, that's not a huge benefit to a lot of people.
Yeah, and especially because of the fact that the GIL's been there for so long, the vast majority of Python code is written with only one thread, right? So it's like, well, I could make your Python code faster, but only if you rewrote all of your code, which not many people want to do.
True. The other major problem or challenge that is there is how does it work with the C extensions that are so important to making Python work well, right? NumPy and all those types of things, right? Yeah. So Larry Hastings was there, and he worked on the Gilectomy, which I think is still the best name of all these projects. The Gilectomy, the removal of the GIL. Yeah. But it sounds like he thinks that Sam's project is already farther than his, so that's great. So maybe tell us a bit about what Sam was proposing there.
So Sam has got this fork of CPython where he has removed the GIL, and it all works. I think there's still a few rough edges, but it all basically works essentially. So now he is looking to. So if you want to, you can try that right now. You can go and download Sam's fork, no GIL, and most Python programs will run fine on it. That's it right there. Yeah. For those watching,
I'll put a link in the show notes.
Yeah.
People can check out the GitHub repo, and it's just a fork of CPython, and then goes from there, right?
Yep. And now Sam is hoping to essentially create a separate mode of CPython that you can enable with a compiler flag, which would enable no GIL. So to get his changes merged into the CPython main branch, essentially. So that would mean that you would have to build CPython separately in order to get a version of CPython where no GIL would work. So it wouldn't be like you'd be able to just open up the REPL and go like import no GIL. It wouldn't be quite that easy.
Right.
But
it is a bit of a hassle that it's literally a separate compilation step, a separate binary, and so on. But maybe it could ship. Maybe the CPython distribution, if this really works out well, could be shipped with that. Like it could be instead of Python or Python 3 or whatever you type, it could be Python NG or something like that. Like some extra command you can run, but at least it would be nice if you didn't have to literally go find a different installer and try to avoid the name clashes of what Python means,
Yeah, for sure. And this is a change from his original proposal. So his original proposal was for a runtime flag. So that would mean that you would be able to, I don't know how exactly it would work, but do something like import no GIL and then.
And reading your write up here, it sounded like Sam has come to the conclusion that there's too many differences for a runtime flag to make sense, and it's got to be a compiled type of thing.
Yeah, exactly. So that was his proposal.
How was the reception?
So there were a lot of questions for Sam. So I think like a few of the other presentations finished under time later on in the summit, and then we went back and asked some more questions to Sam because people still had questions.
Yeah.
So I think everybody in the room definitely knew. So like it's crazy if you look at the viewing figures for these blogs. Like the blog on No Gill is off the charts in terms of how many people have clicked on it and read it since I published it.
Okay.
So it's like the last time I checked, it was like 40,000 people had read the No Gill article, and the next highest was 5,000 people. So,
wow.
So there is a huge amount of interest in this feature, and the people in the room knew that there was a huge amount of interest in this feature. So I think there's a lot of interest in making this work if it can be made to work.
Sure.
But there's just a lot of complications about how to get there. So there were, a lot of people asking what exactly the plan is here, because it's this huge project that Sam's been working on for months and months, and how do you merge that into CPython? You obviously can't have one PR where you have tens of thousands of lines of code changed all at once. So how do you split that up? How do you So I think Sam was looking for a kind of pre-approval before submitting a PEP, and I think some people were reluctant.
Right. Taking the temperature of the room to see if it would if it was welcome or unwelcome, right?
And I think the general mood was sort of cautious, if that makes sense.
Yeah.
It's like yes, but we'd need to see the plan before we give our stamp of approval. That was the kind of vibe I got.
Okay. Yeah, there was some feedback like from Barry Warsaw and Itamar Osterker about the impact it might have on third-party libraries. I think Carol Willing also talked about that, because especially these C layers, or these native code layers, are super common in the data science space, especially. So yeah, some conversation about that, right?
Yes. I think there's a lot of concern about with some features new to the language. For example, with typing was added a few releases back, and I'm very involved in the typing community. I'm massive fan of typing.
I am too.
Yeah,
fan, not involved.
Sure. But it's kind of got a little bit of a bad name for itself in some ways, because there's some people who go to maintainers and sort of demand that type hints be added or whatever.
Right.
And that's not really fair on the maintainers, because everybody's volunteer doing it for free.
It is getting easier, because one of the one of the holdups used to be, well, my library is for Python 2 and 3, and I'm not going to maintain 2 versions and so on, right? So the typing wouldn't work in Python 2. At least now we're generally past that holdup, but still, it's effort that the person might not want to put out there.
And again,
couple of thoughts.
I'm a TypeShed maintainer. I'm very bought into typing. So yeah.
Tell people about TypeShed. TypeShed's pretty cool.
Oh, sure. So TypeShed is the repository of stubs for the standard library, and also a bunch of third-party stubs. So if you TypeShed is like the only version of the standard library that MyPy knows, or Pywrite or PyType or any other type checker.
Mm-hmm.
So like they don't actually know what's going on in the real standard library at all.
Right.
They only know this bundle of stubs in TypeShed. They don't feel like I'm explaining
so
it very
I'll pull up the one for app errors,
but,
and people. These are not PY files. These are PYI files.
Yes.
And if you look at them,
I don't
the
actually know what the I
implementation is
stands for.
super straight. Information? I don't know.
Yeah.
The implementation of all these is super interesting because all the functions are ... and the default values are ... But what you have is you have function name, variable name, type, return value, type, or class, field
Yeah.
type, field type, field type, right?
Yeah. So it's like a Python
I
file with
suspect
like
some people don't even know. Yeah, I suspect some people don't even know that this is a thing you can do to improve the understanding of editors and stuff, right? In MyPy.
Yeah. So a static type checker will use this information to inform the the errors it's flagging on your file if you use it to check a file. So if you import appders in your Python project, then and you install types appders, then MyPy will use the type hints from TypeShed to understand. Oh, okay, this appders instance has an app name attribute and it's of type str.
Do you know what the editors do? Like, does PyCharm already have this information? Does VS Code already have this information from other
So
sources
PyCharm,
behind the scenes?
VS Code does use TypeShed completely. PyCharm, I think, mostly uses TypeShed now. It was kind of.
They used to have their own way.
Yeah, I
because
think
it
it was a bit of a
predated TypeShed.
journey for them to move to TypeShed. I'm not sure if they 100% do yet, but yeah.
Okay. Yeah, very interesting. Let's see. We were talking about the C Python stuff, and Mr. Hypermagnetic asked, "Will C Python ever become Rust Python?" They also point out that type hints save lives. Saves lives. That's great. But back to the first question: did that come up? Did Rust ever come up? My first thought is that's a pretty far bridge, but did it come up?
So there is already Rust Python, I think. You can go and use that if you want to.
Sure.
I think it's quite a long way from becoming the default, from becoming the leading version of the reference implementation of Python.
Right. Interesting. Yeah. Okay. We can come back to that in a little bit because it'll circle its way back a little bit.
Yeah.
All right. So we're halfway through the show, and we've got one of our items done. Fantastic.
Yes.
Let's go to the next one. No, we'll pick up speed as we go.
Yeah.
This other one, this next one is a per interpreter GIL, which actually has been a little bit around from PEP 684, and it's still in draft mode from Eric Snow. And so this also goes back to dealing with the GIL. And it tries to, instead of remove it, say, well, you know what the GIL does is it makes you have single-threaded code. So what we're going to do is, if you want to run a thread, you just start a new sub-interpreter in the same process. And sure, it has a GIL, but it's meaningless because there's only one thread per interpreter.
Yeah.
And so it's a way to kind of sidestep that problem, right?
Yeah, it's kind of funny. So the first talk is like, let's get rid of the GIL. And then Eric comes along and says, but what if we had lots of GILs?
The problem is the GIL's shared.
Yeah.
Although we got to rename it if there's a per interpreter GIL.
Yeah, it's not global.
It should just be a per interpreter IL. The GIL, the G part, the global, doesn't make sense anymore.
A pill? I don't know.
Yeah, a pill. Yeah, that sounds a little bad. But it's interesting to point out, like you pointed out in your article here, that back in 1997, Guido posted something saying, "A massive changes for separate thread state management. All per thread globals are moved to a struct, which is manipulated separately." Basically trying to do the same thing. And it turns out, though, that through another picture that you've got laid out here, there's actually a lot of global state shared across threads and different things, right? That's the problem.
Yeah. So I think if I understand it correctly, and Eric, send me an angry email if I'm getting this wrong.
I have had him on the show before, so I'll link to that episode as well.
Okay, cool. I think it is possible now to run multiple interpreters within the same process, but it just doesn't work very well, if I understand correctly. Right. So it's like, run into all sorts of problems with thread safety and race conditions.
Okay.
There we go. Yeah.
Yeah, so it sounds like he's been working on this for a long time. I think you opened with a funny quote. Hopefully the speaker began. This is the last time I give a talk on this subject. He's been working on it since 2014.
Yeah.
No.
Yeah. I think at the time he gave the talk, he was hoping to get it in for 3.11, but didn't quite make it.
Yeah. Yeah, exactly. So maybe it'll be 3.12. Yeah, because 3.11 is already frozen. Yeah, and it's still in draft mode. Okay, so that's a good one. People can check that out. There's a tension between many of these projects in that the optimizations one are making might be complicating the work the others are doing.
Yeah.
And that's also true for the next one here, which actually I think is the biggest news of Python 3.11.
I completely agree.
Performance improvements. Yeah, performance improvements for 3.11.
Yeah, and I felt like it's a shame that so many more people read the No-Gil one than this one, actually, in a way.
Yeah.
Because I've been watching the CPython repo. I know how much work has been going into this, and I think it's really impressive.
Yeah.
So essentially, the top line news from this is Python 3.11 is going to be about 25% faster than Python 3.10, and this is. So this is mainly a result of implementing a PEP by Mark Shannon. Not sure I can remember the number.
It's known as the Shannon plan. I'm making Python 5 times faster over 5 years or something like that by doing like this 1.25x per year, which they did it this year. That's incredible.
Yes. Yeah. So the main chunk of this is that there are loads of like small optimizations that have gone into this, but a lot of them have to do with implementing what's called a specializing adaptive interpreter. So
what does that mean? What is that?
Well, so this is essentially an interpreter that monitors your program as it's running and spots if you've got like an inefficient bytecode that can do lots of different things. So like maybe it's an add bytecode that could plausibly, I'm almost certainly going to get some details wrong here, but maybe it could add two lists together or add two ints together.
Right.
It's just like a generic add bytecode. And then the specializing adaptive interpreter will spot, oh, hang on, okay, we're in a tight loop here. Only ints are being added here. We can replace this bytecode with a more specialized one, which will do the same thing faster.
Yeah, because there's probably a lot of checks and different types of bits of indirection to let it add strings and lists and so on. But if you know its numbers, then just do the number thing without the checks.
Yeah, exactly. So that's known as quickening. So like as the program is running, the specializing adaptive interpreter quickens your code and replaces the bytecode with a more specialized one. And then and there's actually, have you heard of Brant Booker's Specialist project?
No.
So if you look that up on GitHub, it's a project that he published a few weeks ago, I think, and it's really cool. You can see it's like visualizes the way Python 3.11 will quicken your code as it's running. So I'll send you a send a link.
Yeah, send me a link. Yeah.
Give me 1 second.
You're pulling that up. out in the audience over here, Tomar points out that they've been following the faster CPython repository.
Mhm.
And yeah, I'll link to that as well. Mark Shannon and other stuff. The ideas for making CPython faster over time and different things. Yeah, so yeah, very cool.
Yeah, so that's like their ideas hub with all,
yeah,
talking about how to do it.
All right, let's see. I got your. Thank you. Visualizing its specializing adaptive interpreter. Okay.
Yeah.
All right, very interesting. So this is the thing. Pip install specialist is a thing you can do, and then it'll show you like a printout of the code where it's actually found improvements.
Yeah, exactly. So it will show you where it's quickened your code and where it's been unable to quicken your code. So you can see with I think the green bits here, specialist has quickened those bits of code, but the other bits it's been like, don't know what to do here. Gotta leave it as it is. Yeah.
Yeah. So for people listening, if you just pull up the specialist GitHub repository, which I will put in the show notes, there's a bunch of pictures and colorized code showing you where Python 3.11 was able to make it faster and where it wasn't. This is super cool. I never heard of this. So.
Yeah, and this is a project by Brant Booker, who's been one of the major collaborators on the faster CPython project. So.
Right.
Yeah.
Okay.
It's coming from the top.
It's coming. Yeah, what also is neat is this is not just for 3.11. 3.11 is
the
first step.
They're like only halfway through.
Yeah.
So 3.12
it's pretty well funded too, right? Like Microsoft has, I think, a team of 6 people possibly working with Guido and Mark.
That sounds about right.
And then also Bloomberg has contributed some resources or some help.
Yeah.
And yeah, it's really got a lot of speed here, a lot of inertia behind it, I guess I should say.
And speed, yeah.
Yeah, absolutely. All right. This one, actually, I think this is the big news. I know that it probably didn't make the biggest splash of the headlines, but...
Yeah. I think it's going to, because this is going to make everybody's code faster. It's not like one small micro optimization. It's across the board. So,
right.
Yeah.
The threading stuff is very exciting and interesting, but I'm going to go out on a limb and say I think a lot of people think they need it or they think they want it more than they actually need it. So, for example, if you're running a web site with APIs and stuff, GUnicorn or MicroWizGeet or whatever, they all spin out a bunch of worker processes, and you can have several worker processes per core, meaning you're already like saturating every core of the CPU. So in those scenarios, it's nice, but it doesn't help that much in terms of, a lot of stuff. You don't really need the threading. On the data science side, you might, but at the same time, you're doing the computation in C, or you can use async and await if it's IO bound. There's a lot of ways where this problem is actually already solved. It just doesn't feel like it's solved. And so this one, though, this makes multi-threaded code faster, single-threaded code faster. It just makes all the code faster, which is great.
Yeah. I 100% agree.
Yep. All right. Let's see. What is the next one we want here? Not this one. Yeah. So the next one we want to talk about is this could be a giving it a run for the money. When the listener asked earlier about Rust being the reference implementation for CPython, well, what is it then? RPython? I don't know. Maybe CPython isn't the name for it anymore. The reference implementation for Python. This one here, Python in the browser, could put some pressure to move in that direction, right? So this one has to do with WebAssembly. Tell us about this.
Yes. So this is for a while now. There's been a project called Pyodide, which has been a third-party project, which has been monkey patching essentially CPython to get a version of CPython running in the browser. Right. And Pyodide has been the basis for several cool projects, which are all sort of just starting to take off now. I feel like we've sort of reached this like critical point where it's all finally sort of starting to fit together and make sense. And over the last 2 years, Christian Himes, a core developer, and contributor Ethan Smith have been working to upstream loads of these changes that Pyodide has been making to CPython itself, which will mean that Pyodide doesn't need to monkey patch CPython nearly so much anymore. And CPython essentially will just work in the browser, which would be
there was a
huge.
bunch of changes. Yeah, that's fantastic. There were a bunch of changes made to make this possible, and I can't remember where in the article you said, but
there's a specific
over 60 PRs.
yeah,
and a GitHub issue, right?
Yeah, that's the one. You can just like see the number.
Consider supporting mscripton / WebAssembly as a build target, and guess what? That's now a thing. Now you can actually go in and say -- with mscripton target equals browser as to compile CPython, and that's a big deal. I think it's going to make it possible to use Python where you would have otherwise used JavaScript.
Yeah, for sure. So I think this is possibly one of the biggest gripes that anybody using Python for web development has, is that they then have to like use JavaScript.
Yeah, people will say sometimes to me that I'm being mean or inconsiderate or something when I say that we might not want to write in JavaScript. You're like, why are you hating on JavaScript? I think the frustration that a lot of people feel in the software industry is not that they necessarily hate JavaScript, that JavaScript is the only option. Like there's almost nowhere else in programming where we go, there's one language and one runtime, and that's it. That's all you get to use, period. Right?
Yeah.
On the desktop, on embedded, on the web, like on, server-side web, like you can pick tens of languages at least, right? And you pick the one that works well for you and the one you like. And except for in the browser, everyone is forced to do this one language, which is frustrating.
Yeah.
And so as Python developers, where we like Python, it would be great if we could continue to use a language that we prefer for things like this, right?
And now you can.
And now you can. There's a few challenges with this. One is that the WebAssembly binaries are a bit large. Not huge. They're not huge, but they're like 5 or 10 megs instead of 50K.
Yeah.
So that's a bit of a challenge. But there's places where this is already highly valuable. So for example, if you're doing like an Electron.js app, you could write that largely in Python using this stuff already.
Yep.
And it doesn't matter because you already downloaded an entire copy of Chrome. What's another 10 megs? Is it 200 or 205? Like, I don't care. It's the same,
Yeah. Yeah. I think.
Yeah.
Yeah. I think Simon Willison might have done that a few weeks ago.
Okay. Creating an Electron.js app with PyScript?
Yeah, I think so.
Okay.
I'll
have to look into that. That sounds really fantastic. Let's see. So this is cool because Pyodide is great, but it's like this sort of project maintain alongside CPython. And this is saying the core developers and the team behind Python are allowing you to just compile a limited version directly, right? So Pyodide could say build on top of this one and not have to maintain their own copy.
Exactly, yeah. So we do need to be careful here. Like it's mscripts and the WebAssembly are not fully supported by CPython yet. So there was a lot of concern about that at the summit. Like, if we say it's supported now, then it's a big statement to put out there. So definitely not fully supported yet.
Okay. Good to point that out. And there's plenty of things that are not supported because they're probably not they're not ready. And there are some things that will never, ever be supported. Like tkinter support is probably never coming to the browser.
Yeah.
You know what I mean? Or other things that are not permitted by the browser's sandboxing rules and so on.
Yeah. So obviously if you, anything that can be run in the browser needs to be extremely security conscious, because nobody expects to have arbitrary code executed on their browser.
Yeah, and it sounds very, very suspicious. Like you're going to let me run binary code in the browser, but it's subjected to exactly the same rules as JavaScript, and JavaScript gets JIT compiled to binary code and then run anyway. It just feels better that it's like, oh, here's a script. It's like, no, it's the same thing. So very cool. I do want to just point out, give a quick shout out to PyScript, which you also did in your article. This is super exciting. This takes it and makes it way, way more real. This is where you really do put Python in the browser.
Yeah. So this is built on top of Pyodide, I think. And just enables you to embed Python inside an HTML file, and it just works.
It works pretty well.
Opening tag py-script inside an HTML file. Don't need to download anything. It's pretty incredible.
You can also say source equals app.py in your browser, and as long as that can be delivered as a static file, it'll pull that up and run. I just quick follow up on this one. This is a different one. Irrelevant, but I do want to point out that I don't know if people noticed, I did a video called Python PyScript WebAssembly, and then I actually created an offline progressive web app with it. So once you've installed this app, it no longer has to download that larger binary. So if you look at the code, it's like super, super simple. You can get this cool little offline app, and it is like launch time, down to 1 second, maybe 1.5 seconds. And it's just so bizarre to write Python for like JavaScript events. So you can say like on click equals here's the Python function and all sorts of stuff. So people can check that out. I'll link that in the show notes. But yeah, this is a really big deal. This WebAssembly stuff that's coming in. It's coming from these different angles. It's coming from Pyodide, from PyScript, from the core developers compiling to WebAssembly. All of those things are pretty fantastic.
Yeah, and it's really cool to see so many people collaborate on the same thing at once, from so many different parts of the community.
Yeah, it's true. It's happening. There's two parts where that's happening, right? In this GIL thing and in the WebAssembly side of things, right? Yeah. They're not necessarily coordinating, but they're all working on the same problem, and surely we'll get some good outcomes from that. All right, let's talk about the Cinder one next. So this one does come also from Meta, more Instagram, I suppose directly, but this comes from the Cinder project, and this has to do with some of the optimizations. You want to tell us about this one?
Yeah, so these are essentially async specific optimizations. So Cinder, for those who don't know, is a performance oriented fork of CPython. So the Instagram team essentially we really love Python, but it's a bit too slow for our web servers if we're going to have the whole thing written in Python. So they forked it and implemented there's a ton of different optimizations implemented in Cinder.
Many changes. Yeah, there's a ton. If you check out the Cinder project, there's just a whole list of all these different things. Some of them have to do with JIT. Some of them have to do with immortal objects, and some have to do with other things as well. Async IO. Lazy
imports. It's loads of stuff going on. So with all the attention recently on making Python faster, the Cinder team is hopeful that they will be able to get some of their optimizations merged into the main branch of CPython. So this presentation was specifically about some of the async specific optimizations that they have been implementing in their fork. So essentially, the issue is to do with eagerly awaited coroutines. So if you have a coroutine, then generally, if you have a coroutine function, you'll call that function, and it will create this coroutine object. And that coroutine object doesn't do much until you await it, and then eventually you get a result back. But there's that can be inefficient in some situations, because if the task being done in the coroutine can just sort of finish immediately, then there's no reason to create that coroutine object.
Right. And to schedule it and to do all the stuff on the loop and then wait for it, all of that is just overhead,
Yeah.
right?
Yeah. So what's done in the Cinder fork is they detect when a task can be immediately finished, and like don't bother creating the coroutine object in that case.
Right. So let me see if I can come up with an example for people that might
Yeah,
make it concrete.
kind of
So-
complicated.
Yeah, no, it is, but it's. I think once you get this feel for it, it's no problem. It's not that bad. Probably bad to implement, but not bad to understand. So imagine you have an async function that's going to call an API, but you might have an in-memory cache that says, "Have I already looked this up for this particular argument?" Right. So your code could say, if this value is in the cache, just return that value. Otherwise, await HTTPX get da 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 da. Right. So that first case where you call something that's in the cache, by default in Python now, it's going to still schedule that on the loop, and it's going to make it run on the loop and wait for all that to happen in this inefficient way. So the optimization is like run it as a regular function until you hit an await, and then go through that process, something like that, right?
I think so. Yeah.
That's my understanding, and people can send me messages and let me know I got it wrong. But
Yeah,
I think
exactly.
that's the basic idea. Is there's scenarios where, in my case, if it's in the cache, it doesn't ever really need to be treated as a async coroutine ever. You just get the value back like a regular function. But if it goes past that, then it does need to be one, and that's the distinction, I think.
Yeah.
Okay, cool. So there's actually a lot of improvements and performance things coming from the Cinder project. There's this one, but there was also the lazy imports, right? PEP 690, that one, and so on. Yeah.
Yeah. So on discuss.python.org, there's been I think the discussion has reached over 100 comments now on lazy imports. So if you have views, that is where to where to send them.
Yeah.
Yeah. So that's a whole different proposal, where you could which would introduce an API to enable or disable lazy imports. So with lazy imports enabled, so at the moment all imports in Python are eager. So if you type in import functools at the top of a file, it will execute the entire functools module and then put a reference to that module in your file for you. Whereas with lazy imports enabled, it would see the import functool statement and it'd be like, meh, not going to do anything with that. And then wouldn't actually import the module until the first time functools was referenced later on down the file. And then it would execute
because
the
the
whole
problem
file.
is there's a cost for doing an import. It's not like a hash include, which might be a compile time thing. There's an actual runtime cost for every import. The PEP 8 says all the imports go at the top to keep them orderly.
Yeah.
But if there's many apps that might or might not use some import, depending on what part of it runs, right? And so if you could delay that expense only if you use it, that would be great.
And this can have a major impact on startup time for Python CLI apps. Because it means, yeah.
Nice. Okay. This one. But the one that we were talking about is this this async optimization. So that's the one that was actually covered, but it's one of the things coming out of Cinder, which is cool.
Yes.
And then I think maybe this path forward for immortal objects, is that also coming out of Cinder?
Like no, that's another one.
Similar but not the same.
Yeah, sure. Yes, so this is linked to the per interpreter GIL talk, essentially.
Hmm.
So
Okay.
this is one of those proposals that's kind of very much in the weeds of how CPython is implemented. So it's a proposal to introduce what's known as immortal objects. So an immortal object is, well, an object that never dies. So generally in Python, as we were talking about earlier, objects have a reference count, and if that reference count reaches 0, then the garbage collector comes along eventually and deletes it, freeing up memory that was holding that object. So this PEP proposes introducing a class of objects where the reference count would never reach 0, meaning that the object would never be cleaned up by the garbage collector and would never die. So this would have the advantage.
Why are you bothering to like check on these objects that you know would never ever have any sort of reason to go away, right?
So like there's the none singleton, for example. Like it would be quite rare to have a program that doesn't use none at least once. Or
the number 5, which is pre-allocated, right?
Yeah.
As well as the number 200, like the first -5 and the top 255 or something like that. Yeah.
Yeah. But nonetheless, Python will like doggedly keep a reference count for these objects and like track where they are. So for a lot of these, pre-allocated object numbers, in-term strings, the empty tuple, I think, is also a singleton. The non-singleton, these would all become immortal objects if this PEP is accepted. And that would have, that would, I think, in the short term, make Python a little bit slower, probably. So I think a naive implementation makes it slower by around 6%, but with mitigations, you can make it so that the performance impact is marginal. But then if you do implement immortal objects, it makes things like a parent up to GIL easier. It might also simplify no GIL, I think.
Yeah, probably, because once you know something's immortal and probably also immutable, then you can share it all you want. Yeah.
Exactly. Yeah. So you don't have to worry about. Yeah. Exactly.
Yeah. So some of that state that's really hard to create one per interpreter is like, well, it doesn't change, so here it is.
Yeah.
You don't have to check.
And it just kind of makes sense when you think about it in a way. I think like why would you track the reference count for all of these objects?
Exactly. Like true and false are never going to be gone, so just forget it. Just leak that memory or whatever, right? Yeah. All right, let's see what else we got to cover here. Maybe the issues and PR backlog.
Sure, that's one of the. I think that's the longest one.
Okay, yeah, this is a pretty interesting aspect because it has to do with the developer in residence and Lucas Schlenga and all the improvements that having somebody dedicated to that role has brought, right?
Yeah. So there are a lot of open issues and open PRs on the CPython repo. So this talk was essentially kind of taking a step back and looking philosophically about it and sort of saying, well, what is an issue for? Why there's all these issues. Some of them haven't had activity on them for 5 years or whatever. Like, why is that issue still open? Like, what is that doing for us, really?
Yeah. It's also, I guess, really quick shout out. This is from Irit Catrell.
Yes.
This talk. So I guess it's like two perspectives, right? You see the person who, when they open their phone, at the bottom it has 26,214 unread messages. The versus inbox 0. Like, it's like, well, if we can't close this issue and we can't deal with it within 5 years, it's just friction That's one side of the argument, I suspect, is that's friction. The other people are like, well, this is history.
Yeah,
Historical
and
fiction. What do we do about
yeah,
it?
and I know. Sahi Spochaka, one of the most prolific CPython core developers who's contributed, more to CPython, like I say, so saying, well, sometimes I do come back to issues after 5 years, and I am planning on working on it, but I'm working on a lot of things and have hundreds of local branches, and I'm working on loads of things at once, and sometimes I forget about something for 5 years and then come back to it, which is totally fair.
It is fair,
but I don't think one person isn't going to fix all of those issues. When you've got how many is it now? Let's see, over 6,500 open issues on the CPython repo.
Yeah.
I
don't know how I would actually fall on this. I mean, on one hand, I totally get that you want to keep it around. On the other, if it was something really important, it would probably resurface again anyway. You know what I mean? Like,
no, I completely get that. I think at the moment, my personal opinion is we do have too many open issues at the moment, and a lot of them just aren't ever going to aren't going to get fixed, or if they are going to get fixed, it's not because of the issue being open. Somebody else will just come along and be like, I'm going to fix this now.
I mean, I feel like it's on GitHub now. You could apply a tag to it, like closed due to old age or something.
Yeah.
And just close them. They can be reopened. People could go, well, I really want to see all the ones that were closed due to old age, plus the ones that are open. Just create a search filter that shows that view. Yeah.
If somebody's really bored and is like, I really want to fix some TK-enter feature requests from 20 years ago, then can scroll through those and
right.
Yeah.
All right, for sure. Okay. It's an interesting conversation and discussion and what to think about, but it's not something that directly affects people. Like, that's the perfect kind of thing that's like handled at this meeting, right? Because it's really about those folks.
Yeah.
All right, the final one, the F-string grammar. We got F-strings in Python 3.6, and it's one of the most popular languages added recently, language features. Everyone loves it. I've heard people upgrading to 3.6 and be out or throwing away old versions just so they can write F-strings, which is great. But it turns out that the actual parser for F-strings is kind of insane. I had no idea. Tell us about that.
Yeah. So it's, I think it's, how many lines of code is it? I think I wrote it in the article.
1,400 lines of custom C parser code just for F-strings that's separate from the regular parser.
Yeah, so this whole file is just manually handwritten C code to parse F-strings. And Pablo brought up this crazy slide on that. So this talk was by Pablo Galindo-Salgado. He is a core developer, steering council member, and release manager for Python 3.10 and 3.11. So this is his big project. And Pablo put up this crazy slide showing the dance that the interpreter has to go through whenever it encounters an F string. It's like past.
It sounds really tricky to figure out because you've got all the captured variables. So you got to figure out how to pass those over. Then it goes to the parser, and it's like, oh, geez. Okay.
Yeah.
So what is the idea? The idea is to make this part of the regular parser. Just move this over to like the main, to bring it into the peg parser and all those kinds of things. Okay.
Yeah. So since Python 3.9, Python has had a generated parser. So like you just write all the grammar rules down in this file according to a mini language for the grammar, and then a program will generate a very large C file for parsing Python according to those rules. So it's a much nicer way of doing things. It's much less error prone because you can just generate all this C code instead of writing it all out. And so Pablo's big idea is, let's just move all this f-string parsing into the grammar, do it all at the same time as that. It'll be much cleaner, much nicer to maintain. And it also has some exciting things for users. So it will mean that the core dev team will be able to do some big work on improving error messages, for example, for f-strings. It's currently quite hard to do because, like, if you touch one corner of this C file, could have a chain reaction through the rest of it and cause 10 bugs, and nobody wants that. So.
Yeah, that's great. That's one of the other areas of focus there has been lately on improving error messages. That's good.
Yeah.
3.10 had improvements just in general for error messages.
Yeah.
Maybe that also comes from the peg parser, right? Like maybe that's related. If like the peg parser already has better error messages and you can get this into the peg parser, it'll just bring along better error messages more easily.
So like the peg, so the peg parser is smarter than the old parser. And it has, so like the old parser couldn't like look back when it encountered a syntax error, essentially. So like if it encountered a syntax error, it would just kind of throw up its hands and die on you. Whereas the new parser is able to catch the syntax error and then kind of look around at context and then give you a better error message using that context, essentially.
That's great.
Yeah.
Cool. All right. Well, I think that pretty much, sure. I think that pretty much covers it. Anything else you want to mention to people about the Language Summit?
Anything else?
You wrote it up pretty well, I think, but there's something else.
Yeah. pyfound.blogspot.com is the address if you want to read them.
Yeah, for sure. I'll put the article in the show notes.
I think we've pretty much covered everything. We've covered a lot anyway.
Right on. Yeah, we have covered a lot, Alex. That's great. All right. Well, thanks for all of this and all your work on the other things as well. Before we get out of here, let me ask you the final two questions. If you're going to write some Python code, be it 3.12 or something new, older, what editor are you using?
Good question. I'm actually using Idle quite a lot these days.
Okay. Right on.
I used PyCharm for a while. Then I've tried out VS Code several times. I've never really got on with it. I'm not quite sure why.
Okay.
I loved like all the features PyCharm had, but nowadays I'm just enjoying something that just starts up really quickly and it's just really simple.
Something simple. All right, cool.
Yeah.
And then notable PyPI package or library, something you want to give a shout out to? I mean, we kind of sort of did that in a meta sense with TypeScript or TypeShed rather.
Sure. Am I allowed to shout out my own packages? And
you can shout out what you want. Absolutely.
I'll just give another shout out to Specialist. I think that's really cool. Bernd Böcker's project.
Yeah, Specialist is neat. I'm glad I learned about that today. That's cool. All right. Well,
then I can seem magnanimous by shouting out somebody else's project.
There you go. All right. Well, thanks for doing the write-up. Thanks for taking good notes and sharing it with everyone, because while it makes total sense that the Language Summit is this closed door story where people can have open conversations and, just keep it amongst the core developers, I know everyone in the community really appreciates having a sense of what's coming, where the focus is, what people are worried about, and so on. So thanks for getting that out in the light for us.
Yeah, no worries. It was fun to do. Really fun to have this conversation.
Yeah, you bet. Thanks.
Awesome. Thanks, Michael.